do 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 do. What type of tree? A geometry. All right. With that said, ladies and gentlemen, notebooks, take them on out right now. All right. So, today's learning target. We are going to be talking about understanding the formula for the area of a sector. Okay? So, learning target for today is understanding the area of a sector formula. Now, the area of a sector is similar to that of the area, the arc length. Okay, the arc length was dealing with just a section of the circumference. However, the area of a sector can be viewed as a portion of the area of a circle. Okay, so just like this region here. So that guy right there. Oh, there you go. Okay. So, area of a sector. We will need to understand the angle that we're given. So there's a specific angle which we're given, and a radius of that circle. Okay, those are two components that we will need. Now, let us talk about area of a sector. And there's a few ways to think about it. I mean, there's the textbook definition, and then just kind of like a fun way of thinking about it. All right, the area of a sector is basically a portion of the area of the area contained within a given central angle. So it's the portion of the area contained within a given central angle. Okay, so given a circle, we actually have this region right here. This is the central angle, this angle, and it's the region contained within it. Okay? Alright, so the central angle is just nothing more than an angle that is in the center of the circle. And another way of thinking about this is we can think of this as like the area of a slice of pizza. Okay, I think we all have seen pizza before. Well, last week, we were talking about how the arc length can be considered the crust of that slice. Well, if arc length is the crust of the slice of pizza, the area of a sector is actually the area of that slice of pizza. Alright. Now, I would like to kind of discuss about how we can construct a formula. I know some of you just want to see the formula, but others of you may be interested in understanding how the formula is built. Again, we're kind of considering developing a fraction, and we're thinking to ourselves of area of areas, okay, of a circle, and we're going to relate that to angles of a circle. Alright? So we're thinking about areas in relationship to angles. And again, we're thinking about part divided by whole is equal to part divided by whole. Okay? Now, the part of the area that we're interested in is the area of the sector. Okay? The total area that we're looking at is the area of a circle. All right. Now, this part of the angles that we're looking at is the central angle. So, central angle. Uh-oh. And angle. And the total amount of angles of a circle. Total number of angles, or actually in this case degrees, of a circle. Okay? So, area of a sector, that's that part. The entire area of the circle, whole. The angle of the central angle, so the number of degrees of our central angle, divided by the total number of degrees of a circle. Well, we should know this. Area of a sector, we could just call that AS. Okay? AS. Area of a circle, we just call that A. Central angle, we just call that our A. And then how many degrees of a circle do we have? 360. This is actually very similar to the formula that we've seen last week for arc length. So, finally, to get area of a sector by itself, got to multiply both sides by the angle, the area of a circle. Now that's going to leave us with area of a sector. These guys cancel. Is equal to A times the area over 360. Well, we know the area of a circle is going to be pi r squared over 360. And so that is the formula for the area of a sector. Let us see an example of this. So this is the formula. And this whole discussion here is kind of like how we get the formula made. So we think about setting it up in terms of area to angles. Okay? We think about constructing a fraction, so part over whole is equal to part over whole. Part of the angle over the entire, part of an area divided by the total amount of area is equal to part of the angle divided by the entire angle of a circle, or entire number of degrees of a circle. And so that's how we have the area of the sector is equal to the area of a circle. Area of a sector divided by the area of a circle is equal to the central angle over 360 degrees, the degrees of a circle. Okay. Once we do some basic math, we see that the area of a sector is equal to A times pi r squared over 360. Alright, let's see an example. So, first thing we want to do, get a nice circle. We'll call this example 1. And let us say that the radius of our given circle is 4 meters. And we'll say the angle is 45 degrees. Okay. We would like to find the area of this slice of our circle. Okay. So, first thing you want to do, steps. 1. Write formula. So, writing the formula, we have the area of a sector is equal to A times pi r squared, all over 360 degrees. 2. Plug in what you know. Okay. And you know what? I'll just zoom in a little bit here. So, plug in what you know. Writing the formula. Okay, well, we know the angle is 45 degrees. We have the radius, which is 4 squared. Leave the pi on the side, all over 360. Well, we can reduce this. We know that 45 can actually go into 360 degrees. Well, let's break it up even smaller than that. We know that 9 goes into 45 5 times. We know that 9 goes into 36 4 times. That means it goes into this guy 40. We have 5 up here. Cancel that out. 5 goes into 40 8 times. Okay. And notice that we have 4 times 4, which is 16. We have 16 in the top, 8 in the bottom. Well, 8 and 16 have a common factor of 8. 8 goes into 16 twice. 8 goes into itself once. And we are left with 2 on the top, pi, nothing on the bottom, and yeah, and this is in meters, but since we squared it, it's in meters squared. So the last thing we always got to do is reduce. It is okay to leave it in terms of pi. Usually on standardized tests, the answer is asked to be left in pi. So let's just run through this one more time. First thing what we want to do is just rewrite the formula. Okay. Area of a sector is equal to A times pi r squared divided by 360. Once we've written down our formula, it's important that we plug all the values in. We had 45, 4, and 36. Then we reduce. You could either reduce this in your calculator, but I think it's best if you reduce it by hand. It helps you understand the factors of each number, and also kind of helps you think about what can be related to the top and the bottom to make your number smaller. Okay, so we're done.